Hi, my name is Sabrina.
Hi, my name is Arsh.
Hi, my name is Austin.
Hi, my name is Samir.
In this study, we're analyzing spatial and temporal activity of coyotes and their common prey through camera trap success. Predators such as coyotes vary both in terms of the prey that they hunt and when they hunt. The predator-prey dynamic that they're a part of help bring balance to their ecosystem. However, it is not fully understood how their dynamic is affected by their surroundings. In our research question, we wanted to know how the anthropogenic features and environmental characteristics shape the spatial and temporal activity of coyotes and their respective prey. We aim to understand how the habitat, influenced by both human activities and natural features, affects the behavior and activity patterns of coyote and their prey. Using camera traps, we examine how coyotes adjust their activity based on environmental factors like proximity to trails and vegetation density, and how this influences their interactions with prey.
Our first hypothesis is that predators and their prey prefer to use areas near trails to allow for easier movement and territorial access. This hypothesis stems from previous research indicating that animals often use trails for navigation, which may provide more accessible routes for both predators and prey. Based on this, our prediction was that the camera trap detection frequency of both predators and prey would be negatively correlated with the distance from the camera trap site to the nearest trail. As seen in Figure 1, the number of predator and prey encounters was recorded at various distances from the main trail. Panel A shows 281 predator detections, while Panel B shows 226 prey detections. Linear regression analysis revealed no significant correlation between trail distance and encounter frequency. Through this study, we discovered that the predator and prey species we looked at have no preferences for being closer or farther from trails, which was different from what we expected. These preferences may be species specific rather than a trait common to all predators or all prey.
Our second hypothesis was that predators and their prey prefer areas with dense vegetation to ambush and hide respectively. Based on this, our prediction was camera trap detection frequency of predators and prey will be positively correlated with higher percentages of shrub cover. Unique predator and prey encounters at sites with various amounts of shrub coverage was tested using a linear regression test. 26 unique prey encounters recorded and 281 unique predator encounters were recorded. Based on the results, coyotes showed no preference for high or low density shrub covers. In contrast, prey species preferred areas with less shrub cover. Preferences may be influenced by food availability, safety, and foraging opportunities.
Our third hypothesis was that predators will adjust their dial activity in order to maximize prey access, often leading to temporal overlap. From this, we predicted that the dial activity patterns of predators will align or overlap with the dial activity patterns of their primary prey. To analyze this, we first collected the temporal activity patterns of the mule deer, the eastern gray squirrel, and the coyote to perform a chi-square test. From this chi-square test, we found that the coyotes and mule deer exhibit the same dial activity patterns in nocturnal cycles. However, the eastern gray squirrels did not have temporal activity overlap with the coyotes. This went against our hypothesis that the coyote shared some form of temporal activity overlap with all of its prey. From this, we believe that coyotes do not rely solely on dial activity alignment for predation success.
This study revealed to us that predator and prey activity patterns are dynamic and are influenced by a variety of factors that can be specific to each species. Spatial and temporal patterns cannot be generalized by these two categories, and in future studies, they should be examined at the species level.